Hello and welcome back to the Quality Matters Daily Dive. Now, today, doing something a little bit different. So I saw a really kind of short clip, neat, from Elon Musk talking about the most common mistake made by smart engineers. And I listened to it and thought, yep, I have seen this more than once. I have been involved in the middle of it as well. And actually, it is how I got my start into the health and safety world. Very first accident investigation I was ever involved in. So thought this would be a real fun one to share. Now, this is the first time I've tried to do this here on the live stream. So I'm going to try to share that video with you. I know there's a better way to do it. Maybe if one of y'all know a little bit more about this, you can let me know. But otherwise, we can do the best we can here. So let me go ahead and hit play.
The reason the first step is because it's very common. It's possibly the most common error of a smart engineer is to optimize a thing that should not exist. Right. Okay. And so, well, why would people do that? Well, everyone's been trained in high school and college that you got to answer the question, convergent logic. Yeah. So you can't tell the professor your question is dumb. You'll get a bad grade. You have to answer the question. Yeah. So everyone's basically, without knowing it, they got like mental straitjacket on. That is, they'll work on optimizing the thing that should simply not exist.
And that is unfortunately oftentimes the truth, is we spend a lot of time optimizing, trying to make something better, but we never stop to ask ourselves, does this solution even need to exist? Are we solving an actual problem, or is this some leftover from a previous time or a bad idea that unfortunately got implemented, and here we are years later still working with it? I studied architecture for a few years. I've got a weird, crazy background, makes no sense, but so I studied architecture. And one of the things they talked about is a really cool idea, and I think this applies here, is what they call an architectural ghost. Now, an architectural ghost, if you've been downtown, downtown Houston, it's all over the place, but I'm sure it's true in any large city, is especially these older buildings. You'll see these wonderful windows. And at some point in time, they were framing a shot. And in Houston, it's true. They, at one point, when these older brick buildings were built, they're still right in the middle of downtown, right? They were framing what I have no doubt was a beautiful picture of one of the bayous or a park or a church or something of that nature, right? But now all we've got is this giant glass and steel building right next to this wonderful, beautiful, large window. And you're like, why am I staring at the side of a building? Well, it's what's called an architectural ghost. It had a purpose at one point in time, and that purpose is now long gone, completely forgotten. So we have the same thing in our businesses oftentimes, in our organization. We have a process, but we keep trying to use it and make it work, but we never stop to ask, does it need to exist? So this is where this whole plan, do, check, act process comes into play. So I am going to share the screen here, and I'm going to do a little bit of scribbling for you. So my apologies in advance. My handwriting is absolutely, completely, totally terrible. And whoops. Hang on a second here. Sorry about that. Moved my laptop and accidentally undocked it. So I'm sure we've got a fun little snafu in there. All right, but here's what I want to talk about. We've discussed this before, the integrated process approach, right? So we've got our inputs, our process, our outputs, input, process, output. Then we've got our goal, our controls, our checks and measures. Now, what happens when most folks are trying to make an improvement because they see a problem, right? They see a problem. What they do is they evaluate our inputs, they evaluate the outputs, they evaluate the process controls, and they spend a whole lot of time looping between these three. Well, we got a little bit of a problem if we're spending all of our time looping between these three right here, because if our goal is a bad goal, there's no way at all we can ever make a significant improvement here. In fact, we're going to be doing what Deming calls tampering. Again, my spelling and handwriting is horrible. So the idea of tampering is that we are continually messing with a process that has some sort of a systemic origin. Well, in this case, this goal is no longer a good goal. We need to move on. So we talked about this in a podcast last year. We called it the Three Stooges of Accident Investigation. But I'll go through the basics of it real quick. And this was a really clear example. We had a bad goal and we kept trying to make the process work, but it was a bad goal. So what we had is we had these things that these fuel nozzles, right? So I worked at a turbine company for a while. Oh, come on. Here we go. So we had these fuel nozzles. You can think of them kind of a small cylinder here. And they have what we called, well, come on. Are we going to draw? There we go. They had these rocket tips coming off of them. All right. Now, obviously, I'm not making the most precise of a drawing here. And on the end of the rocket tips, they had little holes. And those holes were there for the fuel. Okay, and the holes had to be aligned at a certain angle, and these rocket tips were so long that way we could get the proper injection into the combustion chamber. All right. Well, what happens is when a company runs liquid fuel through these things, or maybe not the cleanest of natural gas through it, which if you've got American natural gas, hey, we've got really clean, pure natural gas, some of the best stuff you can possibly burn. Some of the stuff coming out of Russia, Saudi Arabia, it's just not the most pure in the world. And, you know, other countries don't care as much about emissions as we do. So God only knows what they actually burn going through these things. So in any case, we've got these fuel nozzles here, and these are set so that you get a very particular spray pattern coming off of them. Very important to have that spray pattern for proper and efficient combustion. Well, what happens is they get all clogged up with, you know, dirt and nasty stuff in there. So what our goal was clean rocket tips. That was our goal, was to clean our rocket tips. Well, this whole thing right here is about 120 pounds for some of them. The lowest was about 70 pounds. Depends on the model. They ranged in weight. Okay. Well, we might have 4 of those. So what they wanted to do is they had a table, okay? And this table, I'll draw a little table here. Hey, going back to my architecture days. All right, and the table had holes in it. And what they would do is they would set that fuel nozzle on top of the table such that the rocket tips came out the bottom here, kind of like so. And so we've got, you know, the orifice there, orifice. There we go. And so what they would do is they would put some sort of a caustic in there to clean it out. Now, what they used was, in fact, industrial strength oven cleaner. And we would fill these rocket tips full of oven cleaner. And that would do a really darn good job of dissolving all the gunk in here. And you might be thinking, well, Kyle, that's going to dissolve the metal. Some of these super alloys is really hard to affect the chemistry on. But that's what they do. And then they take your average garden hose and run it through so that they got all that gunk to spray through. And they do that. Well, this table, mind you, was big and heavy, right? So we've got the weight of the table is about 200 pounds plus another 400 pounds of mass here. I mean, we're looking at a table with a weight of about 600 pounds. Now, this table also had wheels on them on casters. Okay, so this whole table could roll. Well, they had the bright idea, well, man, we could put a lot more fuel nozzles on here and do this a lot faster if we can make the table bigger. So then they made a bigger table that they could put 4 of them on there. So now we've got a really massive table. Then they had the bright idea. See, one of the necessary things with these fuel nozzles was that you would test the spray pattern. Now, the way they would test the spray pattern is they would take that fuel nozzle, right? And they would turn it sideways, like so. And then they would spray water into one of these nozzles through one of the orifices. And then they would watch the spray pattern and they'd take a picture of it. Okay. They had a little plexiglass sheet over here. And I'll draw a little bad camera here. Cool. Ching. They'd take a picture of it. Okay. Not the most accurate thing in the world, but it worked. It served our goal. Okay. So then we would know if there was any damage to any of the outlets on the fuel nozzle. Well, what they decided to do is they wanted to improve this process so that instead of it being here and then having to manually lift and put it up on there, they just made this entire table such that it could rotate upwards and then lock in place. So now you've got 800 pounds rotating upwards. They didn't have a fancy gearbox, nothing automated. It was just two guys lifting and moving it. Well, in the end, we wound up with a guy getting hurt because it was slippery. It's on an angle. One of the guys was smoking. One of them was talking. The wheels didn't lock. There was no cotter pin in place to keep it, to keep it upright. All sorts of stuff going wrong. All in all, we had a total of 11 causal factors that led to the accident happening. Now, guys were literally ready to fight over this. I mean, I seriously had to step in between two guys arguing over why this happened to break them up because they were about to come to blows over this. Because one guy said it was because he was smoking. Another guy said it's because he wasn't paying attention. Another guy said it's because we needed casters on there. Any case, this went on for 6 months with the engineers trying to redesign this table to be more effective and more efficient and safer. Now, I admired the work they were trying to do. This was kind of our first foray into the safety world. And so they really took this seriously, which was a good thing. It was really good. This was a massive turning point. They really took things very, very seriously. The problem was we had a bad goal. See, our goal, as you remember, let me pull the screen back up here. Our goal here was what? To clean the rocket tips. Well, turned out that these rocket tips here weren't all that expensive to begin with. So the process we wound up doing is instead of repairing these and going through this whole process, we decided instead that what we're going to do is we are just going to nix that process. We don't want to do it at all. Come over here. We're going to nix this process. We don't need to do it at all. Instead, what we decided to do is to re-weld these. Here, I'll go back to this other screen. We decided just to re-weld these rocket tips on here. We bought brand new ones. The amount of time and effort it cost actually about balanced out. And in the end, the customer was much, much more satisfied with brand new rocket tips being installed. In the end, we had to develop a small fixture to make certain that we could get these on there on the right angle. But we're talking about a small fixture that weighed about maybe 20 pounds. Very easy for someone to manipulate, move around. Had all the space necessary. The guy could weld it in place. Life's good. We run it through a quick NDE inspection. And no one has to lift anything obscenely heavy or large. No one had to put themselves in any risk or any issue. And man, we spent 6 months and God only knows how many thousands of dollars trying to build these elaborate tables, building custom gearboxes, putting motors on them, calculating the weight distribution. It was a simple solution. But the problem is we were trying to optimize something that just needed eliminated. And the reason boiled down to we did not reevaluate our goal. And we spent all the time working over here. It's our goal. We had a bad goal. So my challenge to you is next time you run into a problem, people are butting heads, can't figure out a good solution. We know we're taking a lot of time and a lot of effort on this, and we're inducing additional risk. ask yourself, how can we eliminate this? Now, some of y'all may or may not be familiar. I imagine if you're probably checking out this kind of geeky quality live stream, you're probably familiar with it. But hey, I'm going to give you the benefit of the doubt. So we have what we call in the safety world our levels of control. I told you my handwriting spelling's bad. A little bit of dyslexia going on there. Little joke, dyslexic, you know, in any case. So the first level of control is what? Eliminate. So every time you have a problem, always ask yourself, can we eliminate it? Can we eliminate this process? Maybe yes, maybe no. But hey, if you can eliminate it, that's awesome. The second one is what we call, see, I've got a problem here. I cannot allow my hand to touch while I am drawing, or it gets very mad at me. So we can substitute is the next one. So we substitute one process for another. In the end, that's what we wound up doing here. You know, 3 is we can have an engineering control. Now, this is part of what they were trying to put in there. The next is we can have an admin control. Admin control means it's a rule. We're going to tell you to do something. And then, you know, down on here, we have PPE. Well, let me tell you, if you find your solution involves these 3, you might ought to strongly reconsider substitute or eliminate. And that always means, always means going back to our integrative process map over here to identify our inputs, our process, our controls. I'm sorry, not our outputs, controls, and our checks. Always go back to this integrative process map. You will be amazed at how many problems you can solve. So take a look at it. See what you can come up with on your next problem. I'd love to hear if you have any fun stories, successes out of it. But otherwise, I hope you guys have enjoyed. If you've not already, do find us over on Rumble. Be sure to subscribe over there. We're really trying to push hard to get a presence going on Rumble. And of course, we're live streaming here on LinkedIn as well. And if you need anything, I look forward to talking to you. Otherwise, y'all have a great day.